been submitted. I asked the town board here in Starkey to submit 2 questions to start this evening off. And Dr. Ingraffea will field the first question, have the first shot at the question, and then it will be followed by Dr. Engelder. The question is, where in the process is the greatest risk of groundwater contamination?
Thank you for that question, and the answer is during drilling and setting of the casing in the cement. That is by far the time of greatest risk to groundwater for reasons that I showed you. It's impossible, technically impossible, to drill, case, and cement a well with absolute security. The well will never fail, not immediately, not ever, any time in its lifetime. So that's the time of greatest risk. There are other risks associated with contamination of underground sources of drinking water, spills at the surface of chemicals that are being brought to the pad, stored on the pad for use as hydraulic fracturing constituents, spills at the surface of the flowback fluid, which is actually more dangerous from a human consumption point of view. So surface spills are the second most important, second likely. The least likely is the one that gets the most press, and Terry and I agree on this one. Terry and I agree a lot. And that's potential migration of frac fluid from the hydraulic fracturing process. It's technically possible. Obviously, the EPA is doing a lot of study on it right now to try to quantify that risk. But I'll conclude by saying that the 3 likely sources in order of probability. Most probable is contamination due to a failure of a cement job or maybe a casing during the drilling and setting of the cement casing. Second, surface spills. The third would be migration.
Yeah, there's another part of the risk. We've seen a lot of brown jugs around, and they've been made famous. And one of the things that industry has learned to do is not air drill through the soil. What that has done, basically, when you air drill through the soil and into the top of the bedrock, is driven a flush of both methane and clay-sized particles sideways. And it's these materials that have gotten into groundwater. There's no poisonous material in this. This is just air and basically the type of stuff that you get with rainwater. There is a very important distinction to draw, and that is the distinction between methane contamination. Methane is not poisonous. A lot of you with water wells have had water wells that have had dissolved methane, and none of you have been affected by it. Methane is usually about, if it is or occurs in larger quantities than is soluble in water, then it can accumulate and become explosive. And the DEC in New York, the EP in Pennsylvania are working very, very hard to see that doesn't happen. That's when methane is dangerous.
Are there any comments to Dr.
Are we in the 4 minute?
Yes, you're in the 4-minute period now. Back and forth.
So yeah, I agree with everything that Terry said. During the drilling process, it's impossible not to drill a well without going through the water table. And the bottom of the hole is open while that's happening. And anything that's being used to stabilize the hole, to lubricate the drill bit, to remove the cuttings, is now going to be exposed to an underground source of drinking water. And it's quite common, whether you're drilling a water well, a gas well, an oil well, to cause disturbance of underground source of drinking water. But I did say very carefully in my comments, it's not only the drilling, but it's also the cementing and casing that can cause problems. I also want to point out that yes, by federal law, the EPA cannot call the wells in Dimmick, and in Bradford County, and in Washington County, which have been found by the DEP to have caused problems with people's underground source of drinking water. The EPA, by law, can't say that those wells are contaminated, because federal law does not allow the calling of methane a contaminant. However, those of you who own your home, or renting your home, or want to sell your home, will notice that if it turns out that you have a large quantity of methane in your drinking water, the value of your property has degraded. If there's a very high concentration of methane, which does occur in some of these cases, then methane can cause an explosion it gets to a concentration in a confined space. It's also now being pointed out in the medical literature that along with methane, there are other alkanes that can cause skin irritation. And methane in your water, in your well water for some period of time, can combine chemically with other things in your well water to cause contamination. This is science that's still underway.
Yeah, it's very important to appreciate that anyone that lives above a source rock is that rock that had organic material in it to begin with, which when subjected to temperature and pressure generates hydrocarbons. Those hydrocarbons over a very long period of time, the Marcellus, for example, is 389 million years old. It's been giving off very slowly these hydrocarbons. Some of them, methane is the most mobile, will sit in many of the permeable formations above. You drill your water wells, you're going to get methane in those water wells. And in fact, it's one of the things that the public has learned in the last 5 years is just how common methane really is in regions that sit above gas shales.
Thank you. The next question from the town is, the town of Starkey has 12 current and plugged gas wells dating back to 1930, ranging in depth from 1,800 feet to 7,200 feet. How can these old wells be made secure to prevent vertical movement of fracking fluid?
Chances are very good that many of these wells are not fracked. The Trenton Black River wells, which are the deepest wells that Jack has referred to, drill down into a formation that's below the Utica and rely on the presence of a very large porosity. And in those cases, frac fluid is not involved at all. Now here we have to make a distinction between this high volume water with additives as opposed to drilling muds that were used to drill the well in the first place. There's relatively speaking, very little in the way of fluids is down there to get around. The shallow wells are probably the older wells. They've sat there for a long period of time, and if they haven't done anything by now to groundwater and in any way disrupted the surface, they're not going to in the future.
So in response to that question, I have two questions. How do you know that there are only 12 wells? New York State DEC claims to know of the 75,000 oil and gas wells for which they have any records for ever having been drilled in New York State. 40,000 wells currently are unknown in their location. The 40,000 wells in New York State, oil and gas, have been drilled, New York State thinks, but we don't know where they are. So how do you know there are only 12 and stuff? Question number one. Question number two, has anybody gone out and inspected those 12 wells at the wellhead to determine whether they're leaking, which of course is a necessary condition but not sufficient condition to determine that they are leaking, because they could be leaking away from the wellhead. So has anyone from DEC come out and checked those 12 wells for you? If not, they should.
So is there anything that you two disagree with in that question?
I think probably we need to clarify the language a little bit. In general, I think, Tony, when the word leaking is used, generally we're referring to methane.
Or whatever else comes up.
Generally we're referring to methane.
You're referring to methane. I'm referring to methane and anything else that comes up.
Okay, please retain your applause until the end of the program. Thank you. Dr. Engelder, would you please comment on the earthquake swarms associated with high-volume hydrofracking in, for example, Ohio and Oklahoma?
Yes, I would. First of all, those Ohio earthquakes were not associated with hydraulic fracturing. They were associated with the disposal of much, much larger volumes of water. And earth scientists have known for years and years and years when large volumes of water, and by large I mean volumes of water that are as much as 2 to 3 orders of magnitude larger than high volume hydraulic fracturing, that amount of water is capable of activating faults that can slip with enough energy released so that they can be felt at the surface. Generally, it's true that when a well is fracked, there are very small pops of energy released. These are called microseismic events. They can't be felt. That's why they're distinguished from earthquakes themselves. And in principle, it is important to appreciate that when water is pumped down in the ground, basically energy is put down there to break the rock apart. And when rock is broken apart, noise, but subseismic noise, is always found when measured with very sensitive instruments.
So everything Terry said is perfectly correct, exactly correct, but let me add to it. The implication is that all seismic events that have been measured at the surface, felt at the surface, have been due to injection of waste products, and that's no longer true. So the British Columbia Oil and Gas Commission issued a report last month claiming definitively, showing definitively, that shale gas wells in the Horn River area of northeastern British Columbia had caused magnitude 3 to 3.5 earthquakes by the hydraulic fracturing process itself. It's the first time it's been in the literature. There's been some debate about whether the fracking process itself could cause measurable at the surface, magnitude 3.5 earthquakes. British Columbia Oil and Gas Commission now claims that it has. So what? Magnitude 3.5 is going to rattle your bookshelf. It's not going to cause any substantial surface structure damage or damage to human health. But here's the problem. That same study showed that because of those earthquakes, damage had been done to the casing and cement of the wells. In fact, a couple of the wells have had their casing crimped and sheared. That's not good. So the source of the energy is under the ground, and there is a problem if we're not careful of drilling too many wells too close together, which is a fundamental issue with shale gas development, because typically speaking, you're only going to have about 150 meters, about 500 feet between your laterals. So if you do cause a magnitude 3.5 earthquake at the surface, it might not cause surface damage, but it is now known to be possible to damage the wells.
I sense that you might have a response to that.
I do. It's in a study that the U.S. Geological Survey has done. The size of the earthquake that is generated then correlates with the amount of water that is put down, so that in areas that have known fault zones, the operators know this because of high-resolution seismic information that is collected ahead of time. They will avoid drilling wells in these particular areas. Do they manage to miss all fault zones? There are some fault zones that are smaller in size that can't be detected by seismic surveys. These, however, are faults that are not capable of causing earthquakes that are of concern.
You have a response? Dr. Ingraffea, you have stated that, I'm going to have a little trouble reading this, emissions could be more harmful from gas than coal long term. Did you voice opposition to Cornell's recent high-volume hydrofracking project to convert from coal to natural gas produced from Marcellus wells? I'm not sure which study they're referring to.
I'm not sure either. Maybe they meant the conversion of the previously coal-fired power plant at Cornell to natural gas. So I'm not sure.
Is the person that asked this question referring to
Yeah,
that?
that's not a fracking question. I asked about the conversion of the HVAC plant going out from coal to natural gas.
The plant itself at Cornell.
Oh, so that's what I guessed just now. I guessed right?
Did you voice opposition?
Yes, I did, and I continue to. It's short-sighted. Cornell did a really good thing by using lake source cooling to substitute for burning coal for air conditioning, and I thought they could have done a lot better with installing. There was an alternative plan, which is to install a wind farm on top of Mount Pleasant. Those of you who are anybody familiar with that? Okay, so Cornell owns lots of land, 14,000 acres in Tompkins County. There's plenty of places for Cornell to install a wind farm. And they could have installed enough wind farm energy to supply a substantial amount of electricity to the campus. They could have expanded the hydro facility on Fall Creek. They could have put a hydro facility on Cascadella Creek. There are a lot of us talking about, let's do a lot of renewables instead of just converting a coal plant to a natural gas plant.
Okay, moving right along, this is addressed to both of you. First to you, Dr. Engelder. I'm curious about the speakers, and I assume this is both speakers, consulting connections to the gas industry.
Dr. Ingraffea and I have both had some experience with the hydrocarbon industry. If we hadn't, we wouldn't be up here right now. And the reality, of course, is that at a university, this is Cornell and Penn State, we have grants that help the types of research that we do. Some of this comes from industry. We have federal grants. You know where that money comes from? Some of those federal grant monies comes from tax dollars that industries pay. The point is that there's a very large system set up to try to understand many of these particular problems, and that system includes laundering money through the government, if I can use a word that might come back and bite, but and then direct industry funding to support the types of research that universities like Cornell and like Penn State do. And I can assure you that it is just absolutely incredibly important that America continue to support the type of work that is done at Cornell, the type of work that is done at Penn State, and in terms of the return on investment for this type of research money, it's been incredibly important over the last 100 years. I can't tell you the number of types of inventions and whatnot that have come from this type of science.
I'll answer the question directly. I began to accept research support for my work at Cornell from the oil and gas industry in 1982. That research support ended in 2002. During that period of time, that research support paid for my graduate student stipend and tuition. A number of graduate students. I was also a consultant to the industry during that period of time, which means I put money directly in my pocket. Since that time, since 2002, I have not accepted a dollar from the oil and gas industry. I will no longer accept money from the oil and gas industry. I have turned down over the last 5 years a number of opportunities to re-engage and do research and consulting with the oil and gas industry on shale gas issues, and I have turned those all down. The issue at the core of this is conflict of interest. So I have very strong feelings about that, and that's why I would now refuse to accept any form of remuneration from the industry or from the public or from speaking engagements, not even travel money, because I don't think it's morally acceptable for someone to voice a strong opinion, an advocacy opinion on something, when someone is taking direct pay for that.
Do you have a response to? Okay, this next question I think refers to something that happened with the SEC shortly after, just before Secretary Cox left office, wherein the rules for calculating reserves of gas were expanded to include unexplored lease areas as well. So the question is, what percentage of the calculated reserves have in fact been recoverable? And I assume that's the calculated reserves that have currently been drilled.
I wish I could, Terry. I'm not an energy economist, and so I don't have any credentials or expertise to begin to answer that question. I'm aware of articles that have been written about it, and I know enough about energy economics to know the difference between a resource and a reserve. And I do know that there are games that can be played both by government agencies that are charged with trying to estimate resources and reserves, and by companies when they're reporting to their shareholders and SEC about resources and reserves. Beyond that, I'm not qualified to answer.
That question is particularly difficult. First of all, you understand that in assessing a gas shale, for example, there is an assessment that takes place before drilling. And that is a volumetric calculation that largely gives you some indication of how much might be there. Then in terms of recovering gas recovery depends on a number of things, including technology and the cost of gas at that particular point in time. Right now, the price of gas is depressed so that a number that industry will say is recoverable from the Marcellus or everywhere else. It's going to be a lot lower now than it was when gas was $8. And these numbers are not hard. I will have to point out, though, that you're aware that the U.S. Geological Survey makes estimates of recoverable gas, of reserves and whatnot. EIA does this. Each of these agencies uses a different technique. I've attempted it in the past, and the USGS, for example, revised their estimate of the Marcellus. The estimate of the Marcellus was a 10-year-old estimate. They revised it upwards to a number that was on the order of 80 trillion cubic feet. And there was a big story in the New York Times stating government reduced reserves or reserve estimates in the Marcellus. They did nothing of the sort. What they did, this is the USGS calculation, increased it 40 times.
That's not quite true. It was one government agency reducing another government agency's estimate. So EIA, which is part of DOE, had an estimate that was about 2/3 of yours, somewhere around 300 trillion cubic feet.
That's right.
And so the New York Times article was saying that the USGS had reduced the government estimate because the DOE's estimate had been reduced. But it is true what you say, that USGS had increased their estimate. So you had one government agency increasing their estimate from roughly, 9 trillion cubic feet to 80. Yeah, okay, and then another government agency having to reduce another government agency. Like I said, there's games that they play. But the fundamental point here is that the resource is how much you think is there. And the reserve is how much you think you can get out given today's technology and today's prices. So the reserve is a constantly moving number, the resource is a constantly moving number, and whatever.
They're moving targets.
Yeah.
So let me follow up for a second here. My understanding is that in the United States, the yearly consumption is around
23 trillion.
23 trillion per year. So dividing that into the estimated total reserves would give us how many years of gas?
Given current prices and current technology, if you believe the USGS number, you have roughly 4 years of supply. If you believe the EIA number, you have 15 years.
It's
So that's somewhat in conflict with what's been stated by the president in terms of 100
That's
years.
Marcellus.
That's just Marcellus. Okay, next question is to Dr. Engelder. How many jobs will be created from gas development in our neck of the woods?
I have to confess, I'm not an energy economist myself. I really am not qualified to answer that question.
Again, I repeat, I'm not an energy economist. I had a number in one of my slides that said 58,000 jobs, permanent full-time jobs, would be created. That's not a number I generated. It's a number that a number of energy economists working on our team generated by looking at what are called amplification factors that are in the industry. For every pad, a certain number of jobs were created. For every well, a certain number of jobs were created. Same thing, for any number of windmills that are created, for every windmill created, a certain number of jobs are created. Solar panel installation, solar panel manufacturing, hydropower, all those industrial activities have standard economic indicators and multiplying factors associated with them. So again, it's like resource and reserve. You can do with them what you want, and you hopefully are conservative so that when you're informing legislators who are about to set policy, that you don't give them wild-eyed estimates that can never be true. And one has to be careful about new jobs versus permanent jobs versus full-time jobs. English is a very important language to get the words right.
Next question, Dr. Ingraffea. When you read about so many water wells around the fracking areas getting ruined by toxic chemicals and gas, is it possible that the pressure from the water and chemicals is pushing the gases, etc., upward into fissures and reaching the wells, or is it from leaking well casing pipes?
That's sort of a replay of one of the very first questions we had, where I ranked the risks associated with contamination of private drinking water wells. And so I'll just repeat what I said. It is technically, physically possible for there to be upward migration of fracking fluid into an underground source of drinking water. There are various scenarios that have been shown by computer modeling for that to happen. The ongoing EPA study is going to try to nail the probability of that happening in terms of how long it would take and the volumes of fluid that might be involved. But I'll repeat again what I said before, it's far more likely, in fact it's factual statistically, that contamination due to failure of cement jobs, possibly casings, contamination due to the actual drilling process, and contamination due to surface spills are far more likely.
Now, there's a law in fluid flow through law of rocks called Darcy's Law. Darcy's Law requires that flow occurs down a pressure gradient. So basically, when a fire truck drives up to a house, water comes out of the hose because the pressure at the fire truck is higher than the pressure at the end of the hose. When a gas well is drilled and production starts, then what happens is pressure along that wellbore is reduced to the point where flow is inward rather than outward. And again, if you maintain that inward pressure gradient, which is what happens, must happen for production, there's little likelihood that flow can occur the other direction because it would defy Darcy's Law.
Okay, Dr. Engelder, how is it morally or logically responsible to take the risk of contaminating the Finger Lakes, one of the largest bodies of fresh water in the world, when fresh water is and will continue to be such a scarce commodity?
Boy, there's a lot of water in the Finger Lakes. It's not clear to me that it's a scarce commodity given the volume of water in the Finger Lakes. I think I made a couple points in my talk. One of them is to show the amount of road salt that's being put on the highways around here. The amount of road salt, year after year after year for the last 100 years, may have had an impact on the Finger Lakes, but the question is, has it? And the volume of water in the Finger Lakes is so large that I don't know that you can actually measure the impact of that huge amount of salt that's being put on the roads. And this then allows the analog to be made that yes, there's a risk. There will be a surface spill or two if this if fractured or natural gas development occurs in the Finger Lakes. But in terms of the scale by volume, the amount of water that's in the Finger Lakes versus the amount of water that's actually involved in one or two of these the spills that will happen. We can't prevent them. You're not going to affect the quality of water in the Finger Lakes.
So I think my reading of the question was a little bit different. It was using the Finger Lakes as an example of a wonderfully, mostly pristine fresh water supply as a microcosm of the Earth's freshwater supply. In many places on the Earth, they are not as blessed as we are. So we shouldn't be profligate with what we have by putting it at risk. That was the question that I heard, and I do think there's a moral question there. So I agree that it's highly unlikely that the spill of one truckload of glutaraldehyde, a biocide, into Seneca Lake is going to ruin Seneca Lake. On the other hand, a spill of glutaraldehyde in one of the streams that people in the stream enjoy fishing will kill every single life form in that stream. And that would be a moral loss. And I don't think it's worth the risk.
Yeah, in terms of the total hydrosphere, looking at water. It turns out that when a hydrocarbon is burned, methane is burned, the products of water and CO2. And in general, these gas wells will return more water to the hydrosphere than is stuck down in the well to begin with.
But if we export natural gas, as the industry has now made up its mind to do, because they don't know how to get the price up again so that it can be profitable, we'll be exporting the natural gas to the United States and burning it someplace else, and the water doesn't return to the hydrosphere in the U.S. It might be going someplace where they need it or don't need it. I would prefer that we keep American water American.
Well, that's not necessarily true. The atmosphere circulates water globally.
Eventually. Tell the people from the Midwest or from Texas whether they really wanted to have their natural gas in the Barnett exported to China when they were experiencing the worst drought in Texas history this past year.
So a follow-up here, on removal, I read a lot about removal of water from the hydrological cycle, and that an average Pennsylvania wells is about 5.5 million gallons per frac. Does that water actually get removed from the hydrological cycle that goes down into the well bores and various, I believe, carries up?
Yeah, I think we just stated that, which is that the methane you burn returns more water, putting it back into the hydrologic cycle than it's removed in the first place. And Professor Ingraffea is right. This is an issue in South Africa, for example, in Peru, where there's very, very little water. The solution there, I think, if they end up fracking, is to pipe salt water from the oceans into the Peru, a couple hundred miles. And basically, then you have nearly an infinite source of water. You have to get a little bit creative about where the water comes from.
News reports recently have stated that Pennsylvania's employment rate has actually gone up and compared to the United States, which is continuing to go down. Why hasn't fracking helped Pennsylvania employment figures?
That's interesting. I had a couple of slides to compare, but I guess we can't show any more on. It'll take too long. So I have one slide, which is a scan of this morning's Ithaca Journal. Anybody read the Ithaca Journal? There's a picture of Governor Cuomo, and it says 1.9% growth rate in New York State, $500 million or more for education in New York State, raising the minimum wage by over $1 in New York State, lots of investment for industrial activity in New York State. And at the same time, yesterday there was an article written by John Henger, former director of the Pennsylvania Department of Environmental Protection, who's now running for governor of Pennsylvania, pointing out what was just said in the question, which is that despite 5 years of very active Marcellus shale development in Pennsylvania, unemployment went up in Pennsylvania as opposed to going down countrywide and going down in the state of New York, and Pennsylvania's state budget is in deep doo-doo. Now, the question is why? I don't know. All I do know is that New York State is doing quite fine without shale gas. And Pennsylvania is not doing quite fine without shale gas.
You might want to ask whoever, because this says news reports recently have stated that Pennsylvania's employment rate has gone up. Yeah, and I think it...
Unemployment.
Was that meant unemployment rate? Because I saw a study recently that the unemployment rate has gone up. Is the person who asked this question still here? Pardon? Unemployment, okay, yes.
Well, all right. Dr. Ingraffea has already indicated that every well pad, every well brings a certain number of jobs to Pennsylvania. So that statement right there is comparing what was happening last year, 2 years ago, when there was a larger number of drill rigs in the state than now. Those drill rigs have left to go to Ohio or other places. Therefore, the rate of employment in Pennsylvania has gone down. That's true.
Okay, the next question goes to Dr. Ingraffea. The yield of gas by hydrofracking is estimated to be 10%. What will happen to the 90% of the gas that's left in the Marcellus or Utica? Will it ooze out over the years?
Wow, excellent question. I'm not sure about the 10%. The latest number I've been seeing in the literature in the Marcellus and the Fayetteville is that the operators think they're getting somewhere around 14 to 15%. Is that about right, Terry? And that number is going to creep up as technology changes. The efficiency of cooperation will go up. Companies are moving towards much longer laterals, many more frac stages, closer spacing of the laterals, and so we can conceivably be seeing something like 15, 16%, maybe more recovery. The second part of the question, what happens to the rest of it? Good question. Will some of it leak? Well, here's the problem. When you drill that many wells, that close together, and you do that much fracking over that long period of time, you're damaging the formation. So as Terry pointed out, there has been some slow leakage over 339 million years that has allowed Marcellus gas to get into people's water, which means it is possible, even given natural pathways, for leakage to occur. The technical question now has to be asked is, as we proceed to continuously damage the Marcellus formation and the formations above it, because they can't keep the fracs in the Marcellus, what are we doing to the possibility of more migration occurring over shorter periods of time? Certainly shorter than 339 million years. And again, I repeat, that's the study that's ongoing by the EPA. Hopefully we'll know in the next 2 years because of measurements and modeling the result of that quantitative risk assessment. Good question.
I should correct the record, however. There are a number of carbon isotope studies that demonstrate that in Pennsylvania, the gas that is found in the Dimmick wells, for example, in the upper part of the Devonian Formation is not generated from within the Marcellus, but rather self-sourced from some of those beds above the Marcellus. It's very clear that there's thermogenic gas sources throughout the Devonian section, which means that in this area, for example, you have the Geneseo gas shale, which is that gas shale exposed at the Gannett Falls. That also generates gas. There are other layers in Pennsylvania above that generate gas. I would point out that with the Marcellus itself, the gas that's being recovered from the Marcellus has been there for the better part of 250 million years, largely because on top of that gas there is a capillary seal. I'm not going to have time to explain exactly what that is, other than to say that that gas has been there an awful long time. And if it hasn't leaked in 250 million years, it's very unlikely to leak over an anthropomorphic period of time.
But that very unlikely needs to be quantified because, let me repeat, it hasn't leaked substantially because we haven't messed around with what's down there. But if we're going to put 100,000 wells in Pennsylvania and we're fracking them with laterals that are only 150 meters apart, and we've got very long laterals, so we're doing a lot of damage to the formation and to the damaging the formations above, perhaps influencing these so-called capillary seals. So we have to quantify that risk.
Yeah, now the problem, of course, I've already mentioned is Darcy's law. You need a pressure gradient to drive the gas out. And there's such a steep pressure gradient that actually comes up the well bore that makes it less likely that these wells will leak around the outside of the casing and the cracked cement.
Less likely doesn't mean impossible.
No, that's right. I mean, I've stated several times in my talk, there is a risk, and we agree on that.
I think the distinction should be made here between thermogenic gas, which is that gas at deep levels, and biogenic gas, which is methane at much lower levels, or higher levels.
Well, that actually, let me butt in here and say that thermogenic gas is the gas that's getting into Dimmick wells. Biogenic gas is generally at the level of groundwater and the like. So there's more than one level of thermogenic gas.
Next question for Dr. Engelder. I have radon in my home, and doesn't that prove that there's a route for gas and other toxins to the surface from some
deposits, rather?
The black shale deposits, like the Marcellus, are found at the surface. I showed a picture of Marcellus, New York, for whom the gas shale is named. There are homes that are sitting right on this black shale. The black shale has a larger component of radioactive materials, which means uranium, thorium, potassium 40. Those homes invariably have shown a higher concentration of radon in basements. It turns out also that homes that are built on granite show a higher radioactivity in the form of radon. That's because granite also is radioactive. The largest radioactive source in homes right now are those granite countertops that are being placed on kitchens so that they look very nice. So that I would worry more about those granite countertops than I would radon in the basement. And it has been shown beyond a shadow of a doubt that homes around Syracuse, for example, which have been built on the Marcellus, are prone to have more radon in their basements than homes that are not built right directly on the Marcellus.
So the answer to the question was yes.
Dr. Ingraffea, in a recent presentation, you talked about better energy sources besides shale gas development. You stated ramping up nuclear and renewable energy is a route to take with the uranium deposit being found in Virginia and companies looking to drill. Poses a question many are protesting this drilling. If a uranium deposit was found in this area, would you support that drilling?
First of all, I never said such a thing. I don't recall ever even intimating such a thing. I certainly am not a proponent of expansion of nuclear power. And I don't know anything about a uranium deposit in Virginia, and never mentioned it. So what was the second part of the question? Now that I disclosed the first one?
Well, if we discovered the uranium here, would you be in favor of it, obviously, by your answer?
Absolutely not. I would like to point out, however, that those of you who read the EID blog, I don't. And I don't think Terry does either. But frequently people will extract things that were written in the EID blog and send them to me in email, so I read them. And there are some interesting things that Terry and I read that we supposedly said that we didn't say.
Yeah, being misquoted is one of the hazards of this business, and both Tony and I enjoyed that immensely. I mean, it makes us sleep better at night, I think, doesn't it? I would like to take this opportunity to point out that there are routes forward. So it doesn't really matter whether it's Tony's plan or my plan. One of the questions is, how are we going to pay for this? And there have been a couple of solutions offered by people who thought about this very carefully. One of them is called cap and trade, which became very popular towards the end of the Clinton administration. And the other proposal is just a straight-up carbon tax. And basically what has to happen, I've already pointed out that to get to a smart grid, that's going to require an incredible investment that I think will exceed the cost of the interstate highway system in America. And we're not in a position right now to be able to pay for that. I would advocate a carbon tax. I think that it's unlikely politically to happen, but just to talk about what a carbon tax is, you drive your automobile, you buy now gasoline for $4 a gallon, but you put a certain amount of CO2 into the atmosphere, and what you would do is then be taxed for that amount of CO2 into the atmosphere, and it would be a healthy tax. $1 more a gallon, $2 more a gallon. I talked about sacrifice. I talked about necessary sacrifice, and it's stuff like this that I think is going to be necessary in order to fund us going into this future that both Tony and I envision.
Yeah, there are various ways of incentivizing a transition, a rapid transition to renewables, and de-incentivizing an increase in the use of fossil fuels. One of them is some form of carbon tax. Dr. James Hansen from NASA, who's well known for his first telling the American people in the Congress about climate change, has written a number of books, one of which I would strongly recommend that you read. It's called Storms of My Grandchildren. And he spends a couple chapters of that book talking about his idea. And I was with him yesterday in New York City. And he again emphasized that the idea is not to tax the American people, it's to pay the American people. So he proposes a fee on carbon. Any company that mines and produces and uses a fossil fuel pays a fee for that production. And in return, that fee is returned to the American people as a rebate, proportionate to how much you don't use carbon. So as you convert your cars and your homes to renewable energy, you get more money back. So it's a reverse tax on the American people and a fee on the companies that are producing the carbon. That potentially solves the political problem of if you're a Tea Partier, you don't want taxes, right? And you want the American people to have complete economic independence, and you want the capitalist system to work according to the market. So Jim Hansen has a great idea. I didn't write it. You should read about it. It's an alternative to what Terry just said, which is incentivizing one thing and de-incentivizing something else.
Yeah, this is semantics. Somehow or another, there has to be a redistribution of wealth. I mean, it's as simple as that. And when I use the necessary sacrifice, we're looking at that. Now, I will have to point out, though, that graph that I showed of the reduction of CO2 put in the atmosphere over the last 5 years because methane has been traded for coal, that was not driven by a federal incentive, one way or the other. That was just pure market capitalism at work at its best. Now, can we rely on that type of pure market capitalism moving forward? I would like to think that was possible. I don't care whether you call it a fee or a tax or something like that. I suspect that acts as a little bit of a prod or an incentive. It's not going to happen as rapidly as Dr. Ingraffea would like to have it happen. And even the way that I would like to see this happen might not be possible without some sort of additional incentives. These are called subsidies, incidentally. And the wind and solar industry right now, per kilowatt hour of generation, is subsidized at the rate of about 100 times the kilowatt hour generation of natural gas fired combined cycle turbines.
I want to add one thing to this issue that Professor Engelder brought up, that the United States experienced an 8% reduction in its carbon dioxide emissions over the last 4 years. That happened for 4 reasons. It wasn't just because there has been a relatively rapid increase in the use of natural gas for electricity generation. Reason number 1 is we use less energy over the last 4 years than we did before. Number 2, we had an increase in renewables, and they don't produce carbon dioxide or methane. Number 3, you and I are becoming more efficient in the use of energy. Our cars are more efficient, our appliances are more efficient, our homes are better insulated. And number 4, in addition to conservation, in addition to efficiency gains, there's conservation gains. We have turned down our thermostats a little bit. We have decided not to use as much air conditioning in the summer. All of those things went into this reduction of carbon dioxide emissions. But what's missing from that is that we increased our methane emissions. And I repeat, it's not just carbon dioxide that's responsible for climate change. It's carbon dioxide and methane. So we reduced carbon dioxide by 8%, we increased methane. And as I pointed out, methane is a much more important greenhouse gas, and the net effect is we're dirtier than we were 4 years ago.
Yeah, this is a very interesting and important debate. The people who study climate change are concerned about whether we look at a 25-year time frame or a 100-year time frame. Because in a 100-year time frame, it is CO2 and only CO2 that really matters. The half-life of methane in the atmosphere is so short that it becomes irrelevant over that long period of time. It doesn't matter how much methane is leaking. So it's a matter of the time scale right in here. And you know, basically, Dr. Ingraffea and I agree on that. He's looking at a 25-year time scale. I'm arguing that it's the 100-year time scale that's more important. The result basically is the same. Schindel, for example, which Dr. Ingraffea showed a couple of graphs by Schindel. He's a scientist at NASA Goddard at Columbia University, where I used to be, has sort of led the way in the analysis of all of this. What do you do when you're burning methane? What happens when you reduce CO2 in the light? And what time frame really matters?
This is a rather topical question. Which film, I believe this is to you, Dr. Engelder, which film is or are more honest representations of the fracking situation? Gasland, Promised Land, or Frack Nation?
We'll start at the extremes. Gasland and Frack Nation represent the two extremes. If you've seen Frack Nation, you know that I appear in that, just briefly, and in fact my wife and I don't watch a lot of TV, and we couldn't watch Frack Nation because whatever channel it was put on, we don't get. I had to call an AP reporter yesterday and say, did that guy who made Frack Nation make me look bad? And the AP reporter said, no, you play a minor role, and it's other people that you make look bad. And then this report, this is Kevin Bagos, incidentally, who I quoted him in another story when I went through my slides. Kevin is right. The guy that made Frack Nation really missed an opportunity. What he missed was the opportunity to say, yeah, industry was responsible for problems in the Demick area, because I haven't seen this, but I think that Frack Nation leaves you with the impression that that wasn't the case. That was an opportunity left on the table in terms of basically trying to get a representation of the center, because what he did was he went just to the opposite extreme from Gasland. Now, Promised Land, I won't give away the plot of the movie, but Promised Land, I believe, is two acts. The first half of Promised Land really starts out, there's one scene, and incidentally, I passed out an op-ed that I wrote for the Pittsburgh Post-Gazette last Friday that offered my opinion of Promised Land, which is that there is a scene in which Matt Damon, who's the star,